Dear students, welcome back. This is Dr. Biju Vasudevan. In this video, we will discuss chapter 4.4 Absolute Maxima and Minima from Calculus 1, Math 111 for week 13. Actually, week 13 has two different topics, 4.3 and 4.4. And you refer your syllabus for final exam. We have not included 4.3 for final exam, so ignore this one. We will discuss absolute maxima and minima is the only video for this week. So how do you find, what do you mean by absolute maxima and minima? Consider an interval in the domain of a function f. Whatever the domain of the function f, we get an interval and a point inside the interval. We say that f is absolute maximum. So for any x, f of x is equal to x square is a function. The domain is from negative infinity to positive infinity, isn't it? What if I give you minus 4 to positive 4 as your interval? In this interval we have to analyze the function, isn't it? If there is a point in between them at which right from negative 4 to positive 4, let it be x dash x0 is a point in this interval. We want to call this point as absolute maximum. So if you find let it be negative 3 to negative 4, then it will be easy to check. If there is a point x0 in this interval, we find f of x0 at the point, and if this value is greater than you want absolute maximum. If this value f of x0 is greater than or equal to any other value for any other x in the interval, then we call f attains maximum, which is absolute maximum for this point. You can check at this point 4, you may find 4 square, all other point will be lesser than this one, so check that one. We will get different examples in this check. In the same way, absolute minimum, if you find an element in this interval for which you will find the function value, and if all other elements will give less greater than this value, f of x is greater than, that is f of x0 is lesser than or equal to any other value of the function in this interval, then this x0 gives, x0 is the value of x at which the function gets absolute minimum. We say that f has absolute extremum if it has either maximum or minimum. Extrema is the common word for maximum and minimum. This is absolute maximum and minimum. We will see here some examples. See this graph in the first case, in both the sides the domain has been, the interval has been given as negative infinity to positive infinity, open interval, isn't it? So it is increasing on both the sides. Therefore only one point at one, when x is 0, you get absolute minimum. So f has absolute minimum, but there is no maximum because on both sides is increasing. This one has no extrema because in this side it is decreasing, this side is increasing. No maxima can be fixed here, it is going. But if you take any finite interval, you can check. In the open interval, infinite interval, it's not, there is no absolute extrema. In this graph, third one, you see, though the domain is given as negative infinity to positive infinity, the function gets the maximum value here and minimum most value at this point, and the function goes parallel to x-axis thereafter on both ends when x goes to positive or negative infinity, isn't it? So maximum most, minimum most values are, though it is going infinitely larger on both sides, isn't it? So this kind of curves will give you both the maximum and minimum, absolute maximum and absolute minimum. So when a function is between a and b, open interval, both the sides, this side is increasing, this side is decreasing, so no absolute extrema. For this one, see, that's just like this curve, second curve b, there is another curve here, y is equal to x type, isn't it? Y equal to mx type curve, but it is given in the closed interval a and b. So minimum most value occurs here, maximum most value occurs at this point, isn't it? So there is absolute maximum and minimum. Fine, there is a theorem. The theorem is extreme value theorem. If a function f is continuous on a finite closed interval ab, if the interval is closed, isn't it? And the function is continuous in this interval, this is the finite interval, and f has both absolute maximum and absolute minimum on in this interval. See, f is continuous in this interval and the interval is closed. In this case, just the previous case here, this is continuous and in the interval it is closed, so we have maximum and minimum. This one, if f has an absolute extremum, either maximum or minimum, in an open interval, not in a closed interval, it's in an open interval, so we cannot calculate f on this a and b because it is open interval. Then the extrema should occur at a critical point. So what is the critical point? Now the question is, what is critical point? Critical point is the function point at which the function does not have a derivative. If there is a derivative, it will be 0. That is, if you find f dash at the point in this interval, it should be 0. Either first derivative does not exist. If exists, it is 0. Such a point, such the value of x is called the critical point of f, isn't it? So if the interval is an open interval and still there is this theorem says, check the statement of these two theorems. The first theorem says is closed interval, so there is an absolute maximum, absolute minimum. Maybe on the end points it's possible, isn't it? Continuous if the function is continuous. But if f has absolute extremum, we know that there is an extremum but it's not a closed interval, then the extremum, maximum, minimum should exist some point between a and b, and that point should be a critical point. Critical point is the point at which first derivative does not exist. If exists, it is 0. That should be remembered, right? Okay. So how to find the procedure for finding absolute extrema? First, find its critical points in the open interval and evaluate all critical points in the given even at the end points. If the end point, if you are giving, see, the given interval is a closed interval. First we will find critical points except a and b inside the interval, isn't it? And we calculate f for all points, open left interval, some critical point 1, critical point 2, critical point 3, and finally b. There are many critical points, you can find some problems, and at every point we can find the value of f, and out of which maximum value will be the absolute maximum, minimum value will be the absolute minimum. That is the third point. So our purpose is first to find the first derivation, make it 0 or infinity, can find the critical points. So find the value of f, original function at f prime, at every point, including the boundary points, isn't it? And the critical points. Choose the maximum value among them or minimum value among them to get the absolute extremum. That's it. Some different information that can be useful to identify the absolute extremum. See, in this curve, what is happening here? When x is approaching, see, this is actually the end behavior of the function. Go back to the concept of limits and check end behavior. When x goes to negative infinity, function is approaching positive infinity. When x goes to positive infinity, function is approaching positive infinity. In both the cases, function is approaching positive infinity. So it should be function is moving up on both sides. So there should be a minimum. So there is absolute minimum. That's the concept. So when both the edges of the function approaches negative infinity, see, second case, when x approaches negative infinity or positive infinity, it doesn't matter. When x goes this side or this side, but the function goes downwards, it will be a parabolic type, that is downward, isn't it? So there will be a maximum, absolute maximum. Third case, when a function takes a different position, when a function goes to negative infinity in one direction, positive infinity in another direction. See, negative infinity in this direction, positive infinity in this direction. Then, what is it? Then as neither an absolute maximum nor an absolute minimum, because there may be local maximum minimum, but there is no absolute maximum. It keeps increasing. It keeps increasing. So it keeps decreasing this side. So there is no absolute maximum minimum. Finally, Again the same in the other direction. When x, this is when x goes to negative infinity, function goes to negative infinity. When x goes to positive infinity, function goes to positive infinity. The opposite, when x goes to negative infinity, function goes to, see, when these signs are two different signs, positive and negative, there is neither an absolute maximum nor an. When these two are same sign, there is, if it is going to negative infinity, there is a maximum. If it is going to positive infinity, in both the cases there is a minimum. So that is the idea from this graph. Here, this is for a curve which has vertical asymptotes, isn't it? So when x is approaching, see, this is x is approaching a from the positive direction, function is approaching positive. In both the cases, function is approaching positive in the same way. So function is approaching positive in both the directions, so there will be a minimum. So but this should be differentiable at this point. So okay, that's minimum, there is a minimum, no problem at all, differentiable or not, because at critical point the function may not be differentiable. Fine. In this case both the signs are same, isn't it? Negative infinity, so it is, function is going downwards in both the directions. When you approach x, when x approaches a from the left side, from the positive direction, when x approaches b from the left side, negative direction, isn't it? So in this case you get a maximum value. When they are opposite direction, neither an absolute neither an absolute minimum nor an absolute maximum. The same for this case as well. Check yourself. Let's continue with the next theorem. Theorem 4.4. Suppose that f is continuous and has extremely one relative extremum in the interval. Exactly one relative extremum. F is continuous in the given interval and has exactly one relative extremum in the interval, then what is the conclusion? F has that relative extremum can be minimum. Now, if the relative extremum is minimum, then you just replace this function x0 at the function, you will get the absolute minimum of the function in the interval. So substituting this value in the function f will get you the minimum value of the function. In the similar way, if that is the maximum at this point, substitute it, you will get absolute maximum. Now let's go to exercise set 4.4. Find the absolute maximum and absolute minimum values of a function. Actually this is of f function f on the given closed interval and state whether those values are right. Question number 7. Okay, obviously find f prime of x. This is not an infinite limit, a closed finite limit. So first derivation, we are going to find the values of function at its every boundary point, left limit and upper limit, and any critical point here. So find the critical points, CP. First derivation is 8x minus 12. So take, this cannot be infinity, so f dash of x can be 0. Take it 0. 8x minus 12. See, you remember, either first derivative does not exist. If exists, it is 0. So first derivative exists here. It's a polynomial, differentiable in this interval. So differentiate it and make it 0. You get this one, 8x is equal to 12. You get x is equal to 12 over 8, which is 3 over 2. So critical point is x is 3 over 2, isn't it? At this this is our critical point. So we have totally 3 points now to find f. What are they? The lower limit is 1 and the critical point is 1.5 and the upper limit is 2. At these 3 points we have to find f and then choose maximum and minimum. So what is f of 1? Substitute in the given function. 4 into 1 square minus 12 into 1. 4 into 1 square, 12 into 1, what is it? 4 minus 12. Minus 8. Actually I have substituted the wrong place. Function is different. Function is minus 10. See, 4 into 1 square minus 12 into 1 plus 10. There is a 10 as well. I missed the 10. So this is 14 minus 2 12. It is 2. F of 1 is 2. And find f of 3 over 2. What is it? F of 3 over 2 in the original function. From here, 4 into 3 over 2 square minus 12 into 3 over 2 plus 10. Okay, this is 4 over 4, 3 square is 9, 12 into 3 over 2, 6 into 3, 18 minus 18 plus 10. So the answer is 19 minus 18, 1. So f of 3 over 2 is 1. We got two values. Here one value, another value here. And find f at the upper limit. 2. So what is f of 2? Substitute here. 2 square is 4. 4 into 4, 16. Minus 2 into 12, 24. Plus 10. That is 26 plus minus 24 is 2. So there are three values now. We will discuss three values. See, I write here f of 1 is 2. F of 3 over 2, it is 1. F of 2 is also 2. So you get maximum value at 2 points, minimum value at 1 point. That is it. So absolute maxima is at x equal to 1. So x is equal to 1 comma 2 gives f max which is 2. And x is equal to 3 over 2 gives f minima which is 1. That's the end of this problem. Let's take problem number 11. This one. See, I will solve 7, 11 and 16. I leave this problem 12 to you to verify. Okay. Problem number 11. Take down this one. The interval given is -1 to +1. So we have a value, b value, isn't it? We have to find if there is any critical point inside it. Fine. 11. I do it here. First derivative f dash of x. You can write this function as 3x over 4x square plus 1 to the power half. So use quotient rule. 4x square plus 1 to the power half and differentiate 3x will get 3 minus 3x into differentiate the denominator half into 4x square plus 1 4x square plus 1 half minus 1, that is half, and then in the differentiate by using chain rule, which is 8x over 4x square plus 1. Now simplify this one. What you get? This is 4x square plus 1 half into 3 times minus this is 3x into 8x, 24x square divided by 12x square into 1 over 4x square plus 1 to the power half, and overall divided by 4x square plus 1, because it will be root square will be power 1, isn't it? Okay. Now finally simplification, take LCM here, cross multiply, and this after cross multiplication this joins here. When you simplify you will get this term 3 over 4x square plus 1 whole power 3 over 2. Here the denominator can never be 0, because for any positive or negative value of x you will not get 0 here. and numerator has no x, so first derivative cannot be 0 nor infinity, isn't it? So no critical point. So no critical point. Therefore, maximum or minimum should be found only on the boundary points. What happens now? Boundary points are negative 1, positive 1s. Find f of negative 1. Substitute x equal to negative 1. So this is minus 3 divided by x square is 1. 4 plus 1 root 5. And what is f of positive 1? It is 3 over root 5. So minimum value occurs at negative 1, which is root 3 over negative 3 over root 5. Maximum value occurs at positive 1, lower limit and upper limit. So you're getting negative minimum and maximum values. This is minimum, this is maximum. That's it. Let me try problem number 12. I'm leaving for you. Again, find all possible critical points in between -2 and 3 and find f at every point. I try 16 is a different one, so I try 16. F of x is given. Find f prime. First write f of x properly by its definition. F of x, this is positive 6 minus 4x in the interval. What is the point at which function is 0? When function is 0 and 6 minus 4x is 0, isn't it? So what do you get? That's what you get. X is minus 4x is equal to 6x is equal to 3 over 2. You see, so when x is less than or equal to 3 over 2, this is positive 6 minus x, negative 6 minus 4x when x is greater than 3 over 2. Just remember this function f of x is equal to modulus x. How do you define? Positive x and negative x, isn't it? When x is greater than or equal to 0, when x is less than 0. This same way we defined this one. Now find derivative of x. Here it is 0 minus 4. And here 0 minus 4 and minus positive 4 when x is greater than or equal to 3 by 2 and x is less than 3 by 2. We know this function is not differentiable at x equal to 0. It will be having a curve like this. So when the sharp edge comes, we will know that at x equal to 0, at sharp edges, function is not differentiable. Okay. So this is also a function which is like this. At x equal, this is 1.5, 2, and here 1, 2, 3, 4, 5, 6. This is a curve going like this, where 0, 6 is intercepting y intercept and 3 over 2 is x intercept. So at 3x equal to 3 by 2, there is a sharp edge, so the function is not differentiable in this one. So you can write f of x is not differentiable at x is equal to 3 over. So only critical point is x equal to 3 over 2. So now we have 3 points: lower limit negative 3, upper limit positive 3, and the critical point 3 over t. So therefore the only critical point is x is equal to negative 3 over, x is equal to 3 over 2, positive 3 over 2, right? Okay, now find, we have 3 values of a lower limit minus 3 and critical point 3 over 2, and the upper limit 3. So find f value at every point. F of negative 3, use it here in the definition. You will find 6 minus 12 plus 12, 18, and f of 3 over 2 is 0. When x is f of 3, y is 0, we have seen it. F of positive 3, minus 12, 6 minus 12, minus 12 is minus 6 and 6. So there are three values. This is maximum, this is minimum. So f maximum is 18 at x is equal to negative 3. F minimum, this is maximum, is 0. So this is not the minimum, 0 is the minimum value. F minimum is 0 at x is equal to 3 over 2. So we found maximum and minimum. That's the end of this problem. Try 12 yourself. The solutions have been given here. Okay, there are 4 problems more. Note down these 4 problems. I'll solve them on a different sheet. Alright, because there is no space here. Okay, solution 21. Is it 21? Problem 21. Check it. The limits, the interval has been infinite interval, negative infinity to positive infinity. So we will check the nature of the function and the behavior of the function, isn't it? Let's check. 21. Limit x goes to positive infinity, x square minus x minus 2. When x goes to positive infinity, the highest degree is even number, so it is positive infinity. The answer is positive infinity. Limit x goes to negative infinity, x square minus x minus 2. Again, since this highest power is so here when x approaches negative infinity, the function is still positive infinity because highest degree is even number. So in both the ends, when x is negative, going to negative infinity or positive infinity, function is approaching. So at this point, there should be an absolute minimum. So there is an absolute minimum at the critical point. So find critical point. Therefore find f dash of x. Differentiate these functions 2x minus 1. 2x minus 1. And let f dash of x is equal to 0. You will find 2x minus 1 is 0. X is equal to half. So this is the critical point at which we will find a minimum value, isn't it? So f of 1 by 2, because we know that if the interval is an open interval and if there is an absolute extreme, that occurs at the critical point. F of 1 by 2 is 1 by 2 whole square minus 1 by 2 minus 2. Use calculator, you will get minus 9 over 4. This is the minimum value. Absolute minimum value occurs at x is equal to 1 by 2. That's the end of this problem. Let's try one more problem. You can use the same concept here. See, here it is even power. I'll give an idea, even power. So when x approaches positive infinity or negative infinity, function will be approaching positive infinity. So there will be absolute minimum, no maximum in this case, just like 21. But here in 25, the degree is 3. So odd number, when x approaches negative infinity, function will go to negative infinity. When x approaches positive infinity, function will go to positive infinity. So it has no minimum, no maximum, isn't it? That will be the case of 25. So we have to discuss only 28 now. 28. Remember this function. We will go. F of x is, what is the problem? F of x is x minus 2 over x plus 1, left open, right closed interval, isn't it? Fine. So we cannot take the lower limit x is negative 1 because it is not closed. So we can take only upper limit x equal to 5, and if there is a critical point in between these two values. Let's find the critical points. So you remember when x approaches negative 1, this becomes infinity, isn't it? Limit x approaches negative 1 from the positive direction, from in this direction. X approaches negative 1 in this direction, positive direction. What is it? F of x f of x will be limit x approaches -1 from the positive direction, x minus 2 divided by x plus 1. There will be infinity, but it's negative infinity. You check by using the tabular method. It is negative infinity, isn't it? So there is no absolute minimum. There is no absolute minimum. Check this one. X approaches 1. So you are taking x is 1, very near to -1. You can take tabular method. So you are approaching -1 from the left, isn't it? So negative 0.9999 you can take and check whether it is negative infinity or positive infinity. So what is the meaning? In the when x approaches so curve, when x approaches -1, curve is going infinitely. This is -1 line. So infinitely negative infinity, isn't it? So no absolute minimum. There can be maximum because right interval is closed. Right side is closed, isn't it? And we can find the first derivative as well. First, f dash of x, differentiate it. X plus 1 differentiate x minus 2 is 1, minus x minus 2 differentiate x plus 1 is 1, divided by x plus 1 whole square. Simplify this one, you get 3 over x plus 1 whole square. So it cannot be 0 nor infinity, isn't it? Yes, it can be infinity x is, when x is -1. But -1 is not in our isn't it? The -1 not included in the interval, so -1 cannot be the value of x. X not equal to -1. -1 not included in the interval, so the function cannot be infinity nor 0. So no critical point. And you remember, for any value of x, f dash of x is positive continuously. It will be positive for any. So f is increasing. F is increasing in this interval. That is, you can write f is increasing. So our question is, so there is no critical point in the interval. Left limit is not included. So only one, and there is no absolute minimum. So only maximum occurs at 5, isn't it? So what is the function value at 5? F of 5. Because x can take only one value, no lower limit, no critical point. So upper limit is 5. F of 5, original value of the function at 5. 5 minus 2 divided by 5 plus 1, which is 3 over 6, which is 1 by 2. So you get absolute maximum 1 by 2 at x is equal to 5. That's the answer. The answer is absolute maximum of f is equal to 1 by 2 at x is equal to 5. That's the end of this problem. Thank you very much. We will discuss the next chapter, applied maximum minima, in the next video.